Silicon Valley operates on the premise that computational scale can eventually transform all social uncertainty into measurable risk. The goal is to deploy enough sensors to eliminate the gaps in our understanding of the world. This contrasts with the classical model of coordination, which relies on the chaotic friction of the open market it measures. By configuring the interface where choices happen, the prediction engine intervenes in the environment it is supposed to be observing. Platform architecture moves the challenge of dispersed knowledge out of the public square and into a private, recursive feedback loop. The problem of coordination hasn't disappeared. It has been internalized within the code. This shift establishes a post-sub-symbolic order. In this regime, economic coordination is no longer negotiated through stable symbols like prices or explicit contracts. Instead, it is calculated by predictive algorithms operating beneath the level of language. Platforms use these systems to capture neurobehavioral traits, mapping the invisible patterns of how users interact with their screens. They use this data to construct the actual architecture of our choices. These choice architectures steer users toward repetitive behavioral outputs. This allows the platform to prioritize its own predictive accuracy over the discovery of genuine pre-existing human demand. This creates a structural dependency. The data being used to train tomorrow's models consists of the modulated behaviors that today's models have already helped to produce. The result is a closed system. The algorithm is effectively learning from its own prior interventions, which changes the quality of the information it extracts from the world. The mathematical consequences of this feedback loop are documented in a study by Shumailov and colleagues. They identified a vulnerability in machine learning known as model collapse. Model collapse occurs when a generative AI is trained on synthetic data produced by its own previous versions. Over time, the model begins to forget the original distribution of data it was meant to represent. This is a standard bell curve representing a healthy dataset. The majority of inputs are in the center, while the tails on the far left and right hold rare events, atypical behaviors, and low-frequency data. As the model trains on its own outputs, it loses information about those rare events in the tails. High-frequency patterns are overrepresented, while the edges of the distribution aggressively dissolve. Eventually, the model converges into a narrow, self-referential spike. It hyper-optimizes for its own mean, erases complexity, and becomes structurally incapable of representing the diversity of the real world. This is the loss of informational exteriority. The model can no longer access inputs that are independent of its own operations, leaving it trapped in an echo chamber of its own prior mistakes. This technical failure suggests that any system relying on recursive feedback will eventually become blind to information that falls outside its own established patterns. There is a heuristic homology between this AI failure and our current platform economies. We can view human economic behavior as a similar distribution space, a scattered point cloud of diverse choices and desires. Recommendation engines function as constraints on this cloud. They steer users away from the edges and toward a homogenized center, where behavior is easier for the algorithm to predict. Researchers call this coordinative atrophy. Atypical choices are suppressed by higher search costs and lower visibility, making the network's behavior more uniform over time. This high predictive accuracy reflects a system that successfully reduced the variance of its own environment. The algorithm isn't better at understanding the market, it's just better at enforcing its own patterns. The platform economy manages behavior through homogenization, which systematically reduces the diversity of signals the system would need to adapt to change. This dynamic mirrors the thermodynamic limits of our physical economy. Nicholas Georgescu-Roegen argued that economic activity inevitably transforms low-entropy resources into high-entropy waste. Karl Marx described a similar extractive crisis in agriculture as the metabolic rift. Capitalist farming pulled nutrients from the soil, but never returned them, leading to a long-term depletion of the land's fertility. We are seeing a digital version of this extraction today. The nutrients of our data economy are being mined without being replenished. In this framework, human spontaneity and unmapped desire represent a low-entropy resource. This virgin soil provides the novelty needed to maintain informational health. The platform acts as a mechanism for conversion. It extracts low-entropy human variance and excretes high-entropy, predictable engagement. Because this novelty is never returned to the user, the system cannot regenerate its own informational base. This cognitive extraction follows the same historical pattern as the industrial extraction of raw materials. It relies on a resource that seems infinite until the system begins to hit its structural limits. A finite cognitive resource that it is progressively depleting through behavioral modulation. These structural limits are best explained by the post-Keynesian distinction between calculable risk and radical uncertainty. John Maynard Keynes argued that some future events simply cannot be quantified in advance. This is the principle of non-ergodicity. Our economic systems are historically open processes. We cannot mathematically derive the probability of a future state solely by looking at the distributions of the past. By erasing the tails of their data distributions, platforms lose the rare and diverse behaviors they would need to adapt to a sudden systemic shift. They become optimized for a world that no longer exists the moment history moves forward. When an exogenous historical shock occurs, whether it's a pandemic or a sudden cultural shift, it functions outside the platform's closed recursive loop. The model, trained on its own previous interventions, has no way to process genuine novelty. The ultimate limit of platform coordination is found in the fundamental ontological openness of historical time. No amount of past data can account for the emergence of a new world. By optimizing so heavily for the reproduction of past patterns, the post-sub-symbolic order leaves society less prepared to metabolize historical change. Repressing uncertainty through recursive modulation does not resolve the underlying problem of economic coordination. It simply masks the growing lack of diversity in the system's signals. The result is an accumulation of fragility. By hiding radical uncertainty under the appearance of algorithmic stability, the tech monopolies create a system that becomes increasingly vulnerable the further it drifts from the friction of actual history.